Now we're going to cover data ingestion. And first up, we have the service known as Cloud PubSub. PubSub plays an important role in making systems more scalable and resilient. In order to understand this role, it's helpful to look at the difference between tightly coupled systems and loosely coupled systems. Now, imagine a system where one component is sending data to another component. In a tightly coupled system, the sender is directly connected to the receiver. There is nothing in between them. This directness makes the system more likely to fail. In a loosely coupled system, there is a buffer, or what's known as a message bus, between the sender and the receiver. Loosely coupling your components makes the system more fault-tolerant and scalable. It also allows message queuing. PubSub is that buffer. It is that message bus. So, in short, PubSub is a global scale messaging buffer or coupler. It is Google's managed version of open source Apache Kafka. And during the test, you may see some scenarios where Apache Kafka appears, and you have to decide whether to use PubSub or Apache Kafka, or how to connect it to GCP components. PubSub is NoOps, also known as serverless, which, as we mentioned previously, means that you do not have to manage or configure any of the infrastructure at all, and that it scales automatically, which is really convenient. It's really amazing. PubSub decouples the sender and the receiver so that systems are more fault-tolerant and reliable. And in terms of how it's used, PubSub is often used for data ingestion. It is often that first touchpoint for your data when it arrives in your GCP environment. It easily connects to other services such as Dataflow. Delivery of each message is also guaranteed at least once. All right, publishers and subscribers. In the name PubSub, pub literally stands for publisher and sub literally stands for subscriber. Another way of thinking about what PubSub does is that it receives messages from publishers and then makes those messages available to subscribers. When we say that PubSub is a message buffer tool, what we mean is that it stores messages published to a topic until they are pulled by subscribers. This is what decouples publishers from subscribers. The publisher doesn't have to wait for the subscriber to be available to receive the message. This ensures reliable and secure message delivery, allowing scalable and flexible communication between different parts of your application or across different parts of different applications. This is especially useful in distributed systems and microservice architectures, where different components need to communicate efficiently without being directly connected. All right, so now for some important terms to know about PubSub. A publisher is an entity, such as an application or a microservice, that creates and sends messages to PubSub. It doesn't need to know who will receive or process the messages. It can just send them to PubSub. A subscriber is the entity that receives and processes the messages. It listens for new messages being sent to PubSub, pulls those messages from PubSub, or has PubSub push those messages to it, and then it tells PubSub that it received the message. A topic is the queue within PubSub where publishers send their messages. Topics have names. A subscription is the stream of messages from a specific topic to a subscriber. When a subscriber signs up to receive messages from a topic, that is called a subscription, pretty much encapsulated in the name. All right, from start to finish, here is an overview of how PubSub is used in a basic implementation. First, a topic is created within PubSub, and it needs to be given a name. Then, once the topic is set up, your publisher, again, it can be an application, a microservice, or a collection of sensors, sends a message to that topic. PubSub holds that message in a queue with other messages, waiting to be served to a subscriber through a subscription. Your subscriber then receives the message. This can be either through pulling the message from the named PubSub topic, or the subscriber can have PubSub push the message to them. This is an important step. After the subscriber has received the message, it has to acknowledge to PubSub that it received the message. And then once PubSub knows that the subscriber has received the message, PubSub can delete it. So, we mentioned that the subscriber can pull messages from PubSub, or we can set up PubSub to push messages to the subscriber. What might be a reason to use one over the other? Pull subscriptions are typically better for batch delivery with a large volume of messages. Push subscriptions, where PubSub pushes the messages to the subscriber, are better for low latency, real-time streaming use cases. In order to do a push subscription, keep in mind that the subscriber must be a webhook endpoint that accepts post over HTTPS. Now, sometimes you're going to have problems with your subscriber. The subscriber might become overwhelmed. It might crash. There might be a bug in its code. Many things could go wrong. PubSub makes all of these things less likely at the system level, but it's still possible for things to go wrong, especially with one component of the system. So if you wanted to know and catch as soon as possible when the subscriber is not doing well, what metrics would you look at? There are 2 suggested metrics that you should track, and these can be tracked in the cloud monitoring part of the Google Cloud Console. First, you should track the total number of messages in the PubSub queue for a subscription. This is important because if you see anomalies or huge spikes in that metric, then it may be indicative of an issue where the subscriber is not receiving the messages. You should also track the oldest unacknowledged message. Sometimes you might have a sudden spike of messages in the queue, and they may all be very recent messages. But if the oldest unacknowledged message is from a long time ago, then you know there's probably something going on. The combination of these metrics is usually sufficient for knowing whether your subscriber is healthy. Okay, you already know that PubSub is Google's managed serverless version of Apache Kafka. Because these tools are so similar and so common, you may find times where you have to use Kafka with PubSub. There may even be exam questions that use Kafka with PubSub. So, some scenarios where you might want to use both Kafka and PubSub include when you have hybrid workloads with some combination of on-prem and GCP. When you're migrating a Kafka architecture to GCP. When you're collecting logs from an on-prem Kafka instance and sending them to GCP for analysis. Or when you have an app in GCP and you're also storing data on-prem using Kafka. GCP has a tool that helps you do this, called the PubSub Group Kafka Connector. There are 2 versions of this connector, the source connector and the sync connector. The source connector reads messages from a PubSub topic and then publishes them to Kafka. The sync connector reads messages from one or more Kafka topics and publishes them to PubSub. In essence, the terms source and sync refer to PubSub and the role that PubSub plays in this setup. One feature of PubSub that is highly likely to appear on the exam is the seek feature. Seek essentially allows you to change the acknowledgement state of messages in bulk, including messages that have already been acknowledged. This means that you can replay previously acknowledged messages. You can seek to a specific snapshot or a specific time. Seeking to a snapshot would allow you to return to the message acknowledgement state of a subscription. Seeking to a time marks every message received before that time as acknowledged, and every message received after that time as unacknowledged. It can also be helpful to set a topic message retention policy. The default is 7 days, and that's also the maximum. All right, next we're going to talk about data flow.